In the last video we looked at the beginnings of completion of the square. Now we're going to use completion of the square to take a quadratic that's in general form and put it into vertex form. And vertex form is one of those valuable forms that there is. This technique also has a number of other applications. Now I'm going to do 3 problems, starting from a relatively easy one to more complicated problems. Now the way that I'm going to begin this, get my pen here, is I'm going to group the term that contains the x squared and the x. That's the x squared plus 8x in this equation here. I'm going to leave myself a little room right here to complete the square, so I'm going to add a term to the equation that wasn't there before, and then I'm going to turn right around and subtract the same number so that I don't change the equation at all. Now I'm going to draw a picture of what I'm going to do. If you don't want to, you certainly don't have to. This is what we did in the last video. I know in order to get an x squared I'm going to need an x and an x. In order to get an 8x in the middle I'm going to need a 4 and a 4. That'll give me an x squared. That'll give me a 4x. Another 4x. Now that's my 8x that I see right here. And finally I'm going to need to insert a 16 that wasn't there before. So now my equation, inside the bracket I've got an x squared plus 8x plus 16. And again, I inserted a 16 that wasn't there, so I turn around and take the 16 out of the equation. And I've still got my addition of 5. Now I factor the trinomial I have right here, but I've already written the factorization up here. That's x plus 4 quantity squared, and I add the negative 16 and the 5, and that'll give me a negative 11. So now I've got a quadratic that's got its vertex at negative 4 and negative 11. I could graph it, I can use it, I could isolate the x easily. It's just a nice form to be able to work with. Now I'm going to do exactly the same thing with the next quadratic. Now this one's a little bit more complicated, and that a right here has become a 3. So before I do my grouping, I'm going to distribute the 3 out of just the first 2 terms. And I'm going to leave myself some room to complete the square right there. And again, you do this just because this is easier than trying to work with that 3. And then I'm going to add a term. I'm going to take the same term and I'm going to subtract. I'm going to get my eraser and get that out of here. Didn't mean to write that. And then I'm going to go and subtract my 10. Now that's always been there. Same thing I did before. I'm looking at the expression that's inside the bracket right now. And I know in order to get an x squared I need an x and an x. In order to get a negative 4 I'm going to need a negative 2 here and a negative 2 here. So I'm just cutting the negative 4 in half. So I've got an x squared, negative 2x and negative 2x. When I add them, that'll give me my negative 4x. And negative 2 times negative 2 will give me a 4. So what I need right now, I've got 3 times, and my perfect square is going to be x squared minus 4x plus 4. Now what I'm going to subtract, I go and multiply back through. There's my original 3x squared, my negative 12x, but what I've actually introduced here is I've introduced a 12. So I'll take the 12 out, and then I've got my minus 10 that came from the original equation. I'll factor the expression. I know that's x minus 2 because I already wrote it up there. And I'll add the negative 12 and the negative 10 to get a minus 22. So now I've got an equation. I've got it in vertex form. The vertex is at 2, negative 22. My multiplier, my a, is the same thing it was before up here. That's 3. That gives the quadratic its shape. But easy to do, and the thing you got to pick up here is, again, when I multiply through at this spot, 3x squared, and I saw that 3x squared right up here, negative 12x, that's right there, but there was no 12. It comes from 3 times 4, so I get the 12 out. As soon as I subtract the 12, I've got 3x squared minus 12x, so I write my minus 10. Same expression that I started with. And now the one I've got here will be a little bit tougher to deal with again. But I'm going to do the same thing. I'm looking at just these first 2 terms. I'm going to distribute out the 4. Leave room to add something so I can complete the square, subtract something because I can't just be adding terms whenever I want to. And I'll put my plus 40 in there. Again, I'm going to draw the square. This part you can skip if you want to. And I need an x and an x, and I cut the negative 7 in half. That'll give me negative 7 halves here, and negative 7 halves here. So I'll get an x squared in this spot. I'll get a negative 7 halves x and a negative 7 halves x. Now when I add those two, I'll get my negative 7x right here. And then I multiply negative 7 halves with negative 7 halves, and I get 49 over 4. Not the nicest number you ever saw. So now I've got y is equal to 4 times, and my perfect square is x squared minus 7x plus 49 over 4. Now I got to find out what I need to subtract. When I multiply back through, there's my 4x squared, my negative 28x, and 4 times 4 over 49 is a 49. So I've essentially added a 49 to this expression. It's not supposed to be there. I'll take it out. And I've got my plus 40 right there. Now the hard work is done. I factored the perfect square right here, but I already know that that's going to be x minus 7 halves because I wrote it up by the box up there. That's squared and minus 9. So what I've got right now is I've got a quadratic, or I've got a parabola with a vertex at 7 halves negative 9 and a positive 4 up here that'll give it its shape. I can go graph it, or I can solve equations with it, whatever you want to do. That's completion of the square. You do the same thing all the time. It's not horribly difficult, but it's really a powerful technique. It's used a lot.